This is Algebra 2, Unit 6, Lesson 8a, the shifted form of a parabola. So what we're going to do is we're going to be working with parabolas, and we are going to be looking at the standard form and other forms to help us identify different things about the parabola. So let's review what we know about a parabola first of all. The standard form of a parabola, which we know is y equals ax squared plus bx plus c. It looks like that. It has advantages in certain application, but it's not always helpful in locating the most important part of the parabola, which is the turning point or the vertex. So what we're going to look at is we are going to look at a different form of the equation of a parabola in this lesson. So let's start about what we know first of all from the standard form. Let's look at y equals 2x squared and y equals negative 3x squared. Without using your calculator, sketch each of the parabolas shown below on your own set of axes and state the coordinates of the turning point of both. Okay, so y equals 2x squared. Now this is in ax squared plus bx plus c form. So first of all, which way would this parabola be pointing? Well, we know that by the a value. This is positive, so it opens up. So when I graph my parabola, it's going to open up in some direction. And we also need to know the turning point. The turning point from ax squared plus bx plus c is the c value. So the c value on this is actually plus 0. There's no c value here. So your y-intercept is actually going to be 0, 0, and the parabola is going to look something like this. So this is at 0, 0, and this points up because the a value is positive. Now the same thing happens here, y equals negative 3x squared. If we have y equals negative 3x squared, the negative tells me that this is going to, because it's negative, it's going to point down. Okay, and again, the c value of this is actually 0, so this is actually also going to be at 0, 0. It's going to point down like this. So this turning point is still going to be 0, 0. So if you have a parabola in the form y equals ax squared, it's always going to have a turning point of 0, 0 because the c value is 0. And remember, a being positive means it opens up, negative it's going to point down. Now we're going to look at develop a pattern to see how a function can have its graph shifted. Now this works for all different kinds of functions. We're just going to look at a parabola first. So we're going to look at the basic quadratic function f of x equals x squared. F of x equals x squared, we know, is going to be pointing up, and it starts at 0, 0, and it's just each point squared. So this is the basic parabola. Now we want to rearrange this parabola to be g of x equals x minus 2 quantity squared minus 4. So let's get the calculator out and see if we can rearrange this parabola. So I put the x squared in the black parabola so that it looks like what's on the paper, and I'm going to put in the blue one y equals x minus 2 in parentheses, quantity squared, minus 4. So I'm going to graph that parabola. So there we go. Here is the original x squared parabola. Here is the blue parabola that we have. So when I graph this, let's see what happened to the vertex. So the vertex ended up on this. It was here 0, 0, and over here it's at 2, negative 4. So 1, 2, 1, 2, 3, 4. Okay. Now let's see. How would you need to shift the graph of fx to get the graph of g of x? Well, we went over 2 and down 4 to get to the vertex. Let's see if that works for the other points. All right, so say I picked this point on the parabola. Pick this point on the parabola, over 2, 1, 2, down 4. 1, 2, 3, 4. That's the same point. So this is going to be a shift of to the right 2 and down 4 for each point of this parabola to become the blue parabola. So let's do that. Over 2, all right, so right 2, and then down 4. So this point, right 2, down 4. 1, 2, 1, 2, 3, 4. this point, right 2, 1, 2, down 4. 1, 2, 3, 4. This point to the right 2, 1, 2, and down 4. 1, 2, 3, 4. And then this point to the right 2, 1, 2, down 4. 1, 2, 3, 4. So there is my parabola, and I'm going to add a couple more points. So I'm going to add the point 1, 1, 2, 3, 4, 5, and the point 1, 2, 3, 4, 5, 1, 2, 3, 4, and I will have my point that I want. All right, so 1, 5, 1, 2, 3, 4, 5, and then over here will be there. So when I draw my parabola, what I have is exactly what was on my calculator. So what we have learned is that we have shifted this to the right 2 and down 4. So the turning point now will be at 2, negative 4. It's this point right here. So where do we see that in the equation? Well, remember our equation is g of x is equal to x minus 2, quantity squared, minus 4. Well, where do we see a 2? The 2 is here, and the minus 4 is there. So remember, the c value is the minus 4, so this is the c value right there on this value, so this is the y-intercept. Well, the y value, the y-coordinate of the intercept. That's the y-coordinate of the vertex. And this is the x-coordinate. So this is a shifted form of the parabola. Let's see if we can figure out exactly how this stuff is going to move when we do these. Let's look at this a little more in depth, of a piece at a time, of why the parabola shifted this way. So the parabola y equals x squared is here, and if we look at the quadratic function, y equals x squared plus 2 and y equals x squared minus 4. What has changed on this parabola? Well, x squared plus 2, that is the c value of the parabola. So where is the y-intercept of this parabola going to be? It's going to be at 2. And since the x-intercept is 0, it's going to be at 0, 2. It's going to be the function. So if I do 0, 2 here, 0, 2 will be right here. So that should be the y-intercept of the function. Now, let's see what happened to the y-intercept here. Y equals x squared plus 2. And I go to the graph. All right, so I already have it entered here. So all I'm going to do is graph this one so we can see it. All right, so the blue one is x squared plus 2, and the black one is y equals x squared. So you can see by doing the blue graph, by saying x squared plus 2, it shifted it up 2. So all the points went up 2. So this point went up 2, this point went up 2, this point went up 2, and each point of the parabola shifted up 2. So we changed the c value of the parabola. So you see we have exactly the same parabola, except it shifted up 2. So if you're adding a constant to the overall function, adding positive shifts it up. Okay, so the parabola is going to shift up. So what do you predict x squared minus 4 is going to do? Well, the y-intercept of x is 0 is going to be negative 4. So if I do negative 4, 1, 2, 3, 4, the vertex ends up down here. So if I go to my graph and graph that one, I have that in here already. So let me turn it on. And there's x squared minus 4. X squared minus 4 is here. So the black parabola is x squared, the x squared minus 4 shifted down 4. Each point shifted down 4. So if I go to graph that, adding a negative shifts it down. So the c value is changing. So it changes the y-intercept. So each point is going to shift down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and so on and so forth. You get the idea. So this is going to be x squared minus 4. So adding the negative, x squared minus 4, shifted it down. and then x squared plus 2, this one right here, y equals x squared plus 2, shifted it up. So the new coordinates of the turning point, x squared plus 2, is instead of going to be at 0, 0, it's going to be at 0, 2. And for the y coordinate, it's going to be at 0, negative 4. So what would the coordinates of the turning point of the parabola y equals x squared minus 150? Well, we know it's going to be 0, but the difference is going to be, the y-intercept is going to be at negative 150. So that's our pattern for the outside term. If it's plus, it goes up. If it's minus, it goes down. Now let's see what happens when we add or subtract a number from the x before it's even squared. So if we have x squared on the graph here, and let's look at x plus 3 quantity squared. So if I do x plus 3 quantity squared, let's see what happens. I've already got it in my calculator. Here's x plus 3 quantity squared. The black one is going to be x squared. So the blue one is going to be x plus 3 quantity squared. So when I graph that, how does this compare to this? It's going to shift how many units? Well, let's see. It went from here to here. It went 1, 2, 3 units to the right. So if I go here on my graph, it's going to go x plus 3 squared is 3 units to the right. 1, 2, 3. And this one, 1, 2, 3. And this one, 1, 2, 3. 1, 2, 3. And then 1, 2, 3. And here is my blue parabola. So that is y equals x plus 3 squared, quantity squared. Now, what about x minus 1 quantity squared? What do you think is going to happen to that? Well, x plus 3 shifted to the left. What's x minus 1 going to do? Well, I bet it's going to shift to the right. Let's see if it does. Here's my red one. Is x minus 1 quantity squared? And I graph it. Yep, it did. So it's going to shift 1 to the right. So it changes inside the parentheses. It's going to shift 1 to the right. Each one goes 1 over. Here to here. This one goes over here. This one goes over here. And draw my parabola. It's going to shift right. Now, why does that seem counterintuitive? Well, it's because of the signs. This one is x minus 1 quantity squared. It goes, the shift is the opposite direction of the sign. So that means the coordinates of the turning points of each of the parabola that we drew in A, the turning point for x plus 3 quantity squared is going to be here at 0, or excuse me, negative 3, 0. I said that wrong. Negative 3, 0. So it's going to shift opposite of this. And then x minus 1 quantity squared is going to be this, is shifted to the right. So this is actually going to be at 1, 0. So if it's inside the parentheses, the sign is opposite for where it ends up. Oh, there's the bell. So let's get the last two here. Determine the coordinate of the turning points of each of the following quadratics. Note the value of A is irrelevant. It doesn't matter what A is right now. We'll deal with that later. So x minus 8 quantity squared plus 5. So that tells me this is going to shift how? Well, the plus 5 means it's going to move 5 up. So my y coordinate is going to be 5. And x minus 8 means it's going to shift to the right. So it's going to shift to the right 8 and then up 5. So that gives you at the point 8, 5. 5 times x minus 1 minus 4, it's going to shift to the left 1 and then down 4, which will be at negative 1, negative 4. And the last one, y equals negative 2x minus 3 squared minus 10. This is going to shift 3 right and down 10, which puts it at 3, negative 10. So that's the basic kinds of shifting that we have. We'll be dealing more with the vertex form or shifted form of the parabola in the next lesson.